Hello and welcome to part 1 of the geometry review. To begin, we're going to warm up with some general knowledge questions concerning definitions, terminology, and other well-known geometric relations. Our task is to decide whether the statement is true or false. If the statement is false, circle the incorrect word or phrase and fix it. Number 1, the alternate exterior angles of two parallel lines cut by a transversal always have the same angle measure. This is true, and this is just by definition. Whenever we have two parallel lines that are cut by a transversal, opposite sides of the transversal and outside the parallel lines are going to have equal measure. So the two angles marked will be the same, and again, opposite sides of the transversal, outside of the parallel lines, those angles will also be congruent. Number 2, the corresponding angles of two parallel lines cut by a transversal are always supplementary. Well, this is false. If we are talking about two parallel lines cut by a transversal, corresponding angles are supposed to be equal in measure. So this angle and this angle are the same, this angle and this angle are the same, and then below them, the two corresponding angles are the same. So really, this should say the corresponding angles of two parallel lines cut by a transversal are always congruent. Number 3, if two lines are perpendicular, well, we know what that means. The two lines intersect at exactly a right angle. Then they form vertical angles at their intersection, which are always acute. Well, no, that is definitely false, because each pair of vertical angles here is going to be 90 degrees, and 90 degrees is right, not acute. To be acute, you need to be less than 90 degrees. So number 3 is false. Number 4, two parallel lines never meet because they lie in different planes. Well, that is definitely false, because by definition, parallel lines need to lie in the same plane. Two lines that never intersect but do not lie in the same plane are called skew lines. So this should say skew. All right, number 5. If two lines intersect in more than one point, they must be the same line. Well, that is invariably true, right? You only need 2 points to create a unique line. So if two lines intersect at more than one point, then they both have those same 2 points in it, which makes it the same unique line. Number 6, two vertical angles cannot be complementary. Well, this is false. If we want to think about, the way in which we have vertical angles, that's two lines that are intersecting. Complementary means that their angle measures sum to 90 degrees. Well, if the two lines intersect in such a way that we have a 45-degree angle directly across from another 45-degree angle, well, 45 plus 45 is 90. Those would, in fact, be complementary angles. So two vertical angles can be complementary when their measures are both 45 degrees. Number 7, there is no angle that is the complement of an obtuse angle. There is no angle that is the complement of an obtuse angle. Well, that's true, right? Because if you're an obtuse angle, that means that you already measure greater than 90 degrees, less than 180 degrees. And if I'm already greater than 90 degrees, I'm beyond the scope of being part of a complementary pair, right? The two complementary angles sum to 90 degrees. So if the angle I have is already greater than 90, no, there's not going to be any angle that's going to create the complement to the obtuse angle. So number 7 is true. Number 8, a figure is said to be convex if, for any 2 points A and B inside the figure, the line segment AB is at least partially inside the figure. Well, that's false. Just by definition, a polygon is considered to be convex if, for any 2 points that you pick inside A and B, the line segment joining those 2 points stays in the figure. entirely. So not just at least partially in there, it's completely in there. So number 8 is false. I guess we would cross out the line segment is completely inside the figure. Number 9, regular polygons must have all equal sides, but do not necessarily have to have all equal angles. Well, again, that contradicts the very definition of it being a regular polygon. This is false. Regular polygons must have all equal sides and all equal angles. That's just by definition. Number 10, a square is a rectangle. Well, that is true, right? Every square is a rectangle, but not every rectangle is a square. The definition of being a rectangle is that you are a parallelogram with 4 right angles. That's the definition of being a rectangle. You're a parallelogram with 4 right angles. Well, yeah, every square is going to be a parallelogram with 4 right angles. What makes it a square and not a rectangle is that all the sides have equal length. So every square is a rectangle, but not every rectangle is a square, because obviously I can draw a rectangle where opposite sides are not necessarily congruent to the other 2 sides. Number 11, a line which intersects a circle at 2 points is called a secant. Therefore, the diameter of a circle is a secant. This is false. Mostly because the definition of being the diameter of a circle means that you are a chord of the circle. A diameter doesn't just have 2 points on the circle. Those 2 points on the circle are in fact the end points of the circle. So our diameter would look, something like that. The end points are points of the circle. It goes through the center point. A secant is not necessarily through the center point. For instance, let me change my color here real quick. The blue line is a secant line, right? It intersects the circle at 2 points, and it continues beyond it. So notice that I continue drawing the line and put arrowheads at the end. That is a secant line. The diameter is a line segment. It goes through the center of the circle. So no, it's not necessarily a secant line. It's a chord that goes through the center of the circle. So 11 is false. Number 12, if a circle is split in half so as to make a semicircle, the diameter now becomes the radius, and the radius is reduced to 1/3 its original size. If a circle is split in half, okay, so imagine that that's our semicircle. Well, nothing happened to the diameter there. Just because the circle was split in half, the diameter is still the same. The radius is the distance from the center point to any point on the circle. All of those spokes of the wheel, if you will, are still going to be the same size r. So this is false. The diameter and the radius stay the same size. Number 13, if a triangle is equilateral, meaning all sides are the same, an equilateral triangle, then it cannot be obtuse. Well, that is true, because if all the sides are the same, all equal lengths, that means that all of the angles inside are going to be the same size. And we know that the sum of the interior angles of a triangle is 180 degrees. So that means each one of these must be 60 degrees, which is an acute angle. So no, they cannot be obtuse. That is true. Number 14, if a quadrilateral is a parallelogram, then it must be a rhombus. False. We can draw a picture to prove it. This is a parallelogram. This side is parallel to this side, and these 2 sides are parallel to each other. Opposite sides are congruent in length. That is definitely a parallelogram, but it's not a rhombus because not all the sides are the same length. So if a quadrilateral is a parallelogram, that does not necessarily make it a rhombus. Only if all the side lengths are the same is it a rhombus. Number 15, if the radius of a sphere is tripled, the surface area is multiplied by a factor of 9. If the radius of a sphere is tripled, well, let's think about what that would be. There's our sphere. Here's the radius. Now, if the radius is tripled, now the spoke from the center point of the sphere to the outside edge is now 3 times as much, 3 times r. How would that affect the surface area formula? Well, let's think about that. For a sphere, the surface area is equal to 4 pi r squared. 4 pi, and then the radius squared. Well, if the radius is itself now being tripled, 4 pi times 3r, triple the radius, and we're squaring it, well, this is going to be 4 pi times 3 squared times r squared. 4 pi times 9 times r squared. So yeah, compare this, compare that to the original formula for the surface area of a sphere, 4 pi r squared. This is 4 pi 9r squared. So yeah, the surface area is being multiplied by a factor of 9. So yes, 15 is true. This concludes part 1 of our review. This is the first 15 problems of the true and false section. We'll pick up in another video with problem 16.